Right. Now in this video I'm going to describe how the fuel gauge of our vehicles, how the fuel gauge works, and also its components like the sending unit that's inside the fuel tank at the back seat, and also the display cluster, the display unit on the display cluster. And after that we will see how to connect this fuel gauge sensor to our Teltonika GPS tracker. As you can see, basically we want to get the information about the fuel level inside our fuel tank through this GPS tracker. And although we can do this, but it's very tricky. Currently some Teltonika devices do support the OBD2 Bluetooth interface, but the problem is not all the devices are GPS devices are OBD2 compliant or do support the Bluetooth interface. And even if they do, it is not necessary that the vehicle that you have is also support the fuel level sensor or give this information through the OBD2 interface to you. But even so, that's why we will use the analog input of this tracking devices to get this information. Now we need to connect the fuel level output that is in our fuel tank and connect this to this analog input of this Teltonika device. Now before proceeding towards the apparently just simple connection of two wires between the two wires of the this tracker and the cluster meter, we must also know that how the fuel gauge sensor actually works in our vehicle, because without that we will not know how all the things are working. And keeping in view that different vehicles we may come up with connection to different and wrong wires, or maybe we could mess up all our wirings. And so as to avoid all these, we must know of which wire of this device to connect to which of the wire of this fuel gauge sending unit or the cluster meter over here. Diagram that the fuel gauge works pretty much the same like a potentiometer or voltage divider. And there is, as you can see, there are two resistances in series connection configuration. As you can see, this is a variable resistance 1. This is a fixed resistance around 110 ohm, and the second there is a variable resistance that is varies between 4 ohm to 110 ohm. This resistance is inside the fuel gauge, our fuel gauge, and this resistance is inside the fuel gauge sending unit that is inside our fuel tank, and it varies according to the fuel level inside our fuel tank. Now in the scenario, let's say, well, the fuel tank is empty, the both of these resistances will be equal, means 110 ohm 110 ohm, and the voltage input volt, that is 12 volt, will be equally divided among two, that is 6 volts and 6 volts. It gives us information that currently our fuel gauge is empty. When the fuel level will be full, the variable the resistance will be the minimum, that is around 4 ohm, corresponding to the 700 millivolt voltage drop across over here. And on the other side, when the fuel tank will be empty, then it will be around 110 ohm, corresponding to the voltage drop over here, equal, that will be 6 volt and 6 volt. Although these values varies according to the type of fuel gauge sending units and vehicles, but in my case it is like that. And on the other side, if the fuel tank connector is disconnected, there will be no voltage drop across over here, and we will get the full 12 volt, and this give us and clue in our various diagnosis if we want. Now here I have our Teltonika GPS tracker FMB 122, as you can see, and this the wiring diagram is given at this back, and it's along with the harness. So as per this diagram, you can see the positive VDC or positive 12 volts and ground are these red and black wire consecutively, and while wires above the red wire are these two wires, gray one and the white one, are basically for the analog input 1 and the analog input 2. This white wire could also be used as an digital input 3, but in this case we could use it as a analog input 2. Any of these two wires could be connected to our fuel sensor in our vehicle. Over here I have removed the back seat of my car, as you can see, so as to expose the fuel pump and the corresponding connector. Now here is the fuel pump connector and the corresponding jack over here. It has five pins, as you can see. Pin 1, 2, 3, 4 and 5. The bottom four pins like 4 and 5 are basically the power supply for our fuel pump, while in the above top pins like 1, 2, 3 are basically for the fuel gauge sending unit. This is basically the positive 12 volts that comes from our cluster meter over here, and the next wire, the next wire beside is basically the positive ground for it, or return through the sending unit, and it also goes all the way to the our cluster meter. As you can see, as the quantity of fuel inside our fuel tank decreases, the resistance in our sending unit increases. The resistance ranges are basically from 4 ohm to 110 ohm. 4 ohm resistance means we have our fuel tank is full, and 110 ohm means our fuel tank is empty. To measure the fuel tank, the current resistance of our fuel tank, let's use the multimeter, set it to ohms, and now check these two wires. Now as you can see that the current resistance is around 10 ohm between these two wires. Now we need to connect our analog input of the Teltonika device to this center wire, or this center wire, or it's actually this yellow wire, not the brown wire. This is a return. These two wires go all the way to our cluster meter panel. As you can see, I have already pre-removed this, and over here now over here this this brown wire is the return, and this yellow and black wire is basically the positive 12 volt that we want. And now I have connected this wire to the analog input 1. I have done this through a continuity testing. I will not go into the detail because you have to check each and every pin for this, and it will be very tedious since I have already done this, so I'm not going into checking of each this detail. Now maybe in your vehicle this connection could be different, so you can, for the sake of simplicity, instead of testing over here, you can also connect directly your analog input to this sensor over here, the yellow wire over there. Since the fuel pump connector, as you can see, is removed and not connected, so let's see what we can see on our cluster panel. Now here on the cluster panel you can see that it shows that our fuel tank is empty. I have connected a small test bulb to the pins of our fuel gauge sending unit, and as you can see the bulb glows, and very lightly glows, because there are two resistances, and that's why. And now we will see what reading we will get at our fuel gauge, and as you can see here is the reading. And now the amount of resistance currently I don't know, maybe somewhat around, maybe this corresponds to the fuel level, and I have simply used this to simulate the fuel gauge sending unit, as currently my fuel tank is full, and so I don't know what actually it will be when the fuel tank will get lower. So I have done this to simulate this. Alright, now I have connected my Teltonika GPS tracker FMB122's analog input 2 to the fuel gauge sending unit of this vehicle, or fuel gauge, and it so as to get the fuel gauge readings or fuel level inputs. Currently my fuel gauge reading is somewhat full, as you can see, nearly full, not almost, and the reading of the Teltonika GPS tracker values are displayed on this cell phone. This cell phone has been connected through the Bluetooth interface to the GPS tracker FMB122. Currently, as you can see, that the ignition has been on, and different values you can see over here. Analog input 1 217 millivolt is basically for temper alarm in this configuration, and this is analog input 2. This reading is 1303 millivolt, or 1.3 volts over here currently. At the time when the fuel inside my fuel tank was full, it was around 650 millivolt. Currently it's 1.3, means I have used some of my fuel, and when once the fuel tank will be empty, it will be around 6 volt, I believe. Although I don't know exactly, since I have not calibrated it or measured it exactly, but I hope that it will be somewhat like that. Analog input to there's 1.3 millivolt. Different vehicles may have different sort of measurements or calibrations, so you have to calibrate your data accordingly once you come to know what is the minimum value as and the maximum value as per your vehicle, so as to map that to the minimum and the maximum of your fuel tank accordingly. And 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 also the measures give you an exact picture of what's going on inside your fuel tank. Thank you.